Welcome to HOS Technologies. Here we are demonstrating automatic power factor correction and plotting the power factor value on the MATLAB. So here we are using the PIC microcontroller. So this is the main microcontroller which can read the voltage waveform and current waveform. So it will find the phase difference between these two and find the power factor value, and it will display the same value on the LCD screen, and it will send the same value through this USB TTL to our laptop. On the laptop we will use a MATLAB coding part to plot the power factor value. So here this microcontroller board and a reset button to reset the microcontroller, and 10k resistor for resetting enable the microcontroller, capacitor to remove the pulses. Though we are using DC, but while working it will give the ripples because we are using the relay. So when the relay is on and off, it will give the ripple pulses. To neutralize them, we are using the capacitor and LED resistor for current limiting. That's 330 ohm, and this is a 5-pin to programming the microcontroller. So this is a programmer. From this programmer we are going to load the programming to the microcontroller, and once the program got loaded, and when you switch on this motherboard, it will start reading the input from the given input signals from the current sensor and the voltage current transformer and the voltage transformer, and find the difference angle. If it is below 0.9, so it will switch on this relay. This relay will connect the parallelly this capacitor to this R and L loads. Then the current waveform will be leads. Automatically the power factor will be compensated. So whenever the only R load is there, so the power factor is near to the unity, maybe 0.95932 based on the resistance and this value. And whenever added this L load in series with this bulb, so then the power factor will be comes down based on this inductance. So the current waveform lags. So the microcontroller will sense that and switch on this relay. This relay will connect this capacitor parallelly to this 2, nothing but R plus L. So then power factor comes up and current waveform leads. So parallelly the power factor will be improves, coming to the near unity. So let us go with the demonstration. So switch on the power supply. So initially let it settle down. So initially it will give the fluctuating values, means the current waveform and the voltage waveform has to settle down because it's the 20 milliseconds of duration, right? So now it's lagging, right? So only lagging, it will be switching between these values, only lagging. So after some time it will settle down to some value. So and now connect the USB TTL to the laptop and open the MATLAB and open the MATLAB code. So this is a MATLAB code we are going to provide. Put these two files in one folder. This is smoothing file is for just smoothing the curvature instead of getting the sharp edges to smooth edges. So now get the COM value from this device manager which I explained in the previous video, and now enter the COM number value here. Okay, enter the COM number in the starting only. This is a COM 4. Okay, it's a very third line, and now run the code. So after some time, so the power factor value will be right, plotting over there. You can see this power factor value. Okay, so now I added the L load, means these two are connected in series, R plus L. So that's why the voltage will be divided, and parallelly the bulb index will be comes down, right? So lagging. So as you can see, this power factor also comes down, and the capacitor got switched on already by the microcontroller, and it will take as usually some time to settle down the power factor, right? So now it increases so slightly, and after some time it will be comes to the normal position. So it will take some time to settle down the power factor value. See, now it's settled down. So as you can see this, right? Thank you.